Hello students! Welcome back to Teacher Koi YouTube channel. We are already on our second quarter for grading science lesson. Our topic is all about the history of an atom. At the end of the lessons, you are going to explain how the quantum mechanical model of the atom describes the energies and position of the electrons. Have you ever gazed in awe at a beautiful fireworks display and wonder what makes those dazzling explosions of color and light possible? It all comes down to the incredible world of atoms and the science behind them. Fireworks are a perfect example of how the properties of atoms and molecules can create a mesmerizing visual spectacles. Maybe some of you ask question, what is an atom? How does it look? Let us first identify what we call atoms. The Greek called this particle atomos, which means indivisible. In the modern word, atom is derived from this term. Atoms are the basic building blocks of matter. Anything that takes up space and anything with mass is made up of what we call atoms. And atom has different structures. The first one is a proton, or also known as a positively charged particles or a subatomic particle with a positive electrical charge. For the second one, we have electron, a negatively charged particles or a negatively charged subatomic particle that can be either bound to an atom or free. The third one is the what we call neutron, or also known as the neutral particles or the subatomic particles found inside the nucleus of every atom. It's trivia time! Did you know that the proton, or the positively charged particles, was discovered by Ernest Rutherford on 1909? And on 1897, electron, or the negatively charged particles, was discovered by J.J. Thomson. And on 1932, the neutron, or the what we call neutral particles, was discovered by James Chadwick. It started with the idea of Democritus. He taught to what we call theory of atomism during 5th century before Christ era. According to him, all matter is composed of small invisible particles called atoms. Atoms were uniform, solid, hard, incompressible, and indestructible, and that they move in infinite numbers through empty space until they stop. Democritus believed that indivisible and indestructible atoms are the basic component of all matter in the universe, and this is how Democritus' model of an atom looks like. The next one is we have John Dalton. Dalton's atomic theory was known as the solid sphere model. According to him, all matter is composed of extremely small particles called the atoms. Atoms of a given element are identical in size, mass, and other properties. It cannot be subdivided, created, or destroyed according to John Dalton. This theory helped explain how different chemicals mix together and what makes them different, just like this one. The next one is we have J.J. Thomson. Proposed the what we call plum pudding model in the late 19th century. According to him that all atoms contain tiny negatively charged subatomic particles or electrons. The electrons were embedded in a uniform sphere of positive charge. This is how the plum pudding model of all atoms looks like. A plum pudding is a solid pudding or bread which has plums. Today, we call this raisin, dispersed throughout. The whole pudding is analogous to an atom, and the plums are the parts inside the atoms. Next one is we have Ernest Rutherford. He proposed the what we call nuclear model. In 1911, he described the atom as having a tiny, dense, and positively charged quark called the nucleus. So established that the mass of an atom is concentrated in its nucleus. The light negatively charged electrons circulated around the nucleus, much like planets revolving around the sun. According to this theory, atoms have a nucleus with a positive charge and most of the mass, surrounded by electrons that orbit like planets. It explains why particles can pass through our bounds of atoms, and it is the basis of our current understanding of atomic structure. One is we have Niels Bohr. He proposed the planetary model. In the year 1913, he proposed a model of an atom in which the electron was able to occupy only to certain orbits around the nucleus. Niels Bohr proposed an atomic structure model describing an atom as a small, positively charged nucleus surrounded by electrons that travel in circular orbits around the positively charged nucleus like planets around the sun in our solar system, with attraction provided by the what we call electrostatic forces. One is we have what we call Erwin Schrödinger. Proposed the what we call quantum wave model in 1926. His model conceives of electrons as undulations of matter, that is, it described the wave behavior of an electron. He suggested that the movement of an electrons in the atom correspond to wave-particle duality and consequently electrons could move around the nucleus as a standing waves. Generalize once again the evolution of atomic theory. For the first one is we had the atomism by Democritus in 5th century BC. According to him, all matter is composed of small invisible particles called atom. In 1803, we have the solid sphere model by John Dalton. According to him, atoms are invisible and compounds are combination of different types of atoms. On 1897, we have the plum pudding model by J.J. Thomson. According to him, that the atom is a sphere, but the positive and negative charges are embedded within it. And in 1911, we have the nuclear model by Ernest Rutherford. According to him, that electrons orbiting in a set, predictable paths around fixed, positively charged nucleus. And on 1913, we have the planetary model by Niels Bohr. According to him, that electrons are arranged in concentric specific circular orbits around the nucleus. And for the last is we have in 1926, the quantum model by Erwin Schrödinger. The location of the electrons could only be described as being part of a cloud around the nucleus. So it's time to test your knowledge about the history of atom. So all you had to do is to prepare your pencil and paper. Okay, for the first one, all you had to do is to identify the missing letter. For the first one, it is the basic building block of matter. Very good, it's atom. He proposed the plum pudding model. Very good, it is J.J. Thomson. It is a subatomic particle with a positive electrical charge. Anyone? Okay, so we have proton. A negatively charged subatomic particle that can be either bound to an atom. What is that? Very good. It's an electron. Good job, everyone! Finish this lesson with these quotes. The atoms may seem to be random, but God is in the details. That is according to Victor J. Stanger. If you learned something new on my video lesson, please don't forget to like, subscribe, and share my videos. Thank you everyone and God bless. See you on my next video lesson. Bye-bye.